Mine is like stay up till 6 a.m. every day and then sleep till 3.
Sounds like a great schedule.
For break, it's good. Not when I'm starting school.
Probably not.
I went to bed early enough last night, but my phone didn't blown up for the night.
Oh, okay. So we started factoring. It's kind of the last thing that we covered. We took GCFs out, or common denominators out. We did all those different kind of things, greatest common factors out. We did all these different types of things. And one of the last things we did was we worked on factoring by grouping a little bit. So the first thing we're going to do is we're just going to do a couple review problems. Start out by factoring by grouping today. Just to kind of get everybody back into kind of a mode of how we go about factoring. And then we're going to talk about how do we factor trinomials today and how do we go about that. So the first one we're going to look at today, 3k cubed plus 9k squared minus 2k minus 6. Remember when we're factoring by grouping. Factoring by grouping simply means that we group the first two terms together, factor out a GCF. So we'll put these two together, factor out a GCF. We'll put these two together, factor out a GCF, and then hopefully what we have inside parentheses is the same. So if we factor, we take those first two, and we take out a common factor, number-wise. I think we can all probably agree that it's 3. Variable-wise, remember we go to the smallest exponent, so 3k squared is our common factor. And then remember what we're going to do, again, just as a reminder then, what we do is we take each of these parts and divide each of those parts by 3k squared to see what happens. If I take 3k cubed divided by 3k squared, the 3's cancel out, leaving me with 1k, plus 9 divided by 3 is 3. K squareds cancel each other out. So there's the first one. The second set, if we take a GCF out of the second set, remember we always said take the negative out. 2 and 6, well, it's 2. And then we're going to put our parentheses. So we're going to divide each of these by negative 2. Negative 2k divided by negative 2 is k. Negative 6 divided by negative 2 is positive 3. So our first factor, our common factor for them was k plus 3. And then we're left with 3k squared minus 2. And that ended up then being our solution for that problem, factored by taking out the GCFs with factoring by grouping. Why don't you go ahead and try this one. Let's go 49 n cubed plus 14n squared minus 56n minus 16. See if you can factor that one out by finding a common factor. As you're kind of finishing up this one, just kind of give you a little bit of a heads up as to where we're at and what we're doing over the next week and a half, 2 weeks. There's only 2 weeks left in the semester. We do only have one assessment left. At least that's all we have planned. Right now is one assessment left. Probably, what's today? What hour is this? 6th hour? You'll have a test next Wednesday.
Then our like final.
That will be your final too. Yep. You're not going to have a final cumulative final. The final that you guys have is just going to be over what we're doing right now. And actually the assessment is just from what we're doing today through what we do next week. And a lot of it's just going to be, yeah. All right, so if I look at the first two, what's the GCF? 7n squared. So that leaves me with 7n plus 2. Common factor for the second one, -8. Is that right? Yep.
Yeah.
So then that leaves me with 7n plus 2. So the factor of this is 7n plus 2 and 7n squared minus 8. Any questions with that? Okay, so there's just a good review over what we've been doing or what we were doing prior to break and kind of get you back into the mode of what's going on. The next thing we're going to do is, you notice we had 4 terms within those last ones. The next things we're going to do is we're going to work on, okay, how do we go about factoring if it's a trinomial, meaning that it has 3 terms. Okay, so we've done this kind of in one direction. If we had n plus 8 times n plus 1, and I asked you to multiply that, there were 2 ways that you could multiply this. We either used FOIL or we used the box method to multiply these out. If we used FOIL, first times first, n times n is n squared. O stood for outside. N times 1 is n. I stood for inside. Inside was 8 times n, or 8n. And the L stood for last. 8 times 1 is 8. Then we combined like terms. So we had n squared. The outside and the inside, generally you could combine them. So that would be plus 9n. And then plus 8. And that was our solution if we multiplied them. If we use the box method, we put the n and the 8 there, the n and the 1 there, and then we just multiplied n times n to get n squared, 8 times n, 1 times n. You get the same thing. What method you used, we didn't care. So we used kind of that FOIL method or that box method to kind of distribute the multiplication. Now we're going to work on going in this opposite direction. So how do we go from a problem, how do we go from what we call a trinomial, which is 3 terms, and more specifically a quadratic trinomial, meaning it's something squared and 3 terms. How do we go from that back to the factored form of it? I want you to watch, I'm going to have you watch this guy do this. I just want you to watch. I do not want you to write anything down while he's doing it. I just want you to kind of watch this gentleman as he goes through his method for factoring. And I'm going to straight out say that on a YouTube video wise, as far as YouTube videos and guys that, and teachers that are quick and easy to watch, this guy is really, really good. Okay? He taught forever. He doesn't teach anymore. He's got his own little YouTube station. But he does a really, really good job. Nice
Austin asked a very great question.
4 minutes. Just
Not
watch.
that Austin in the last row asked a great question. T squared plus 8t plus 12. The question asks, well, he didn't ask a question, so he knows it's not him. Huh? Yeah. All right. So
Brian Austin Green, shut up.
there you go. So what we look at here is, with this we have t squared plus 8t plus 12. All right. What we're going to do is, it says factoring, and what we previously factored on factoring, like I already talked about, we took a number, okay, and we broke it down into its prime factors, right? And then last time we took a factor and we broke it down into a product of two factors, right? That was by distributive property.
Factor
So
by
remember,
grouping.
ladies and gentlemen, when I say factor, what I mean is write it as a product of its factors. So we look at this and we say, what goes into all of these? And you might say, well, 1, yes. What goes into besides 1 or of those? So is there any other number or term?
2, 4.
Well, we get stuck with t though because the 12. Nothing, right? They don't have a GCF that we can factor out. You always want to look if you can pull out a GCF. In this problem, we don't have a GCF. So, well, we can still factor it, right? Because factoring just means writing it as a product of its factors. So what is a number that divides into this? Or what is a term that divides into it? Yes? No, you can't combine them because this is t squared and this is to the t power. Okay? So you can't combine them because they're not like terms. Huh? 12 and 8. No, because that has a t as a factor and that doesn't. So you can't combine them. So what I want to do is I want to write this as a product. And do you guys remember multiplying binomials? FOIL? Okay, we're going to have to go back and review that. What I want you guys to do is, this is a factor, all right? And what we're going to do is we're going to take two binomials. Well, if we know we're going to have t times t. T times t is going to give us t squared, right? Yep. What we need to do is determine what are my last two numbers that multiply to give us 12, but add to give us 8. Okay? Right, so a lot of times what I like to do, all right, this is the way I like to do it. I like to set up a nice little x, okay? Up top, I write a times c, where a times c, or a is your coefficient of t squared, which in this case is 1, and then c is my constant. So a times c is 12, and then b is 8. Okay? If you guys want to write that down, it's a very, very helpful hint to do. What two numbers do you multiply to get to your constant, but then add to get to your middle term? Okay? So then you think. You said your last two numbers were 6 and 2, right? So therefore, positive 6 and positive 2. Now, is this problem written as a product of a multiplication problem? Yes, right? You're not adding between these two factors. You're multiplying between the two factors. And what I wanted you guys to do to check your work, do you guys remember how to multiply binomials? We'll have to probably review that. Multiplying binomials, remember you can use FOIL. First times first, which would be t times t, right? The outer, t times 2. The inner, 6 times t. And the last, which would be 6 times 2. So you get t squared, 2t, 6t, and 12, which gives you t squared plus 8t plus 12. So therefore, is this multiplication of this problem?
Yes.
Yes, it is. Okay? So yes, when you write it as a product of two binomials, it's just another way to write this. All right? Again, guys, all we're doing, we're not changing the problem. We are just reworking the problem, so it's now written as a multiplication problem. Okay?
Okay, so the big piece that I wanted you to see out of that is, one, I mean, if you want to look that guy, I'll look up his name. He does a good job, but he does nice little quick stuff. His videos are only like 2 or 3 minutes long, or 4 minutes long. But he does really a pretty nice job of explaining it. Obviously, he was doing that one inside of his classroom. He doesn't always do it inside of his classroom. He actually doesn't even teach anymore. I think this is just like he's a YouTuber now and just does math YouTube videos, which they are what they are. Okay, so we're going to factor. So we started out with, we're going to kind of work backwards, and I'm going to kind of explain to you what he just did. So we've got n squared plus 9n plus 8. And this is just the problem that we worked on. And we're going to make this a product of two binomials. What you put first, what you put in your first two pieces, which would be these green boxes here and here, it's just going to be your variable in this case. Now, what I do want you to understand, the ones we're going to do over the next couple days, there's only going to be an a value of 1. The number out in front of the squared next couple days is only going to be 1. It'll change next week. But what you're going to put inside of those first two green ones all the time is it's just going to be your variable. So because my variable is n squared, I'm just going to put an n there and an n there. Because if you think about the first, it's n times n, which is n squared. So we've got that part taken care of. Now, this x method that he uses, this is kind of big. This is what we all use too, and that's why I liked what he does. Other teachers teach this guess and check, kind of try to figure out what works. Everybody here at AHS uses kind of this x method to do it. And how we figure out what goes where. On the top, it's going to be your a value times your c value. Now keep in mind, remember when we write these in standard form, and we've already talked about this before, in standard form is an squared plus bn plus c. A can't be 0, but a, b, and c are just numbers. They're the numbers that are out in front of each of those pieces. So in this case, my a value is 1. Don't want to use that one. My a value, there's nothing written there, so we can just assume there's a 1 there. So I'm going to take 1 times 8. So 1 times 8, that's going to give me my top number of 8. What goes on the bottom of the x is my b value. The b value is the value of the middle term. So in this case, it's 9. I'm going to erase this, make it red. This is my b value. So now what I'm thinking through my head is I'm looking for the factors of 8 because these two middle numbers, both here and here, those two numbers need to multiply together to be 8 and add together to be 9. So I'm looking at all of my factors of 8. So if I look at the factors of 8, what numbers multiply together to be 8? Well, 1 times 9, 1 times 9, 1 times 8, right? 2 times 4. Are there any others? No. But if I look at those two, which ones add up to be 9? 1 and 8. So if I put a 1 here and an 8 there, I ask myself the question now, is 1 times 8, 8? Yes. Is 1 plus 8, 9? Yes. So since that's true, then the first term is going to be n plus 1 because there's understood to be a plus sign there. And the second one is going to be n plus 8. Again, because there's understood to be a plus sign there. And we'll talk about how we know what plus and minus is here as we kind of go along and look at different questions. But now, this is kind of that factored form, the product of two binomials. And that's what we're shooting to do today, is get that product of two binomials. And you can always check it. First, n times n. Outside, 8n. Inside, n. Last is 8. N squared plus 9n plus 8. That's what we started out with, so we know that it works. That n plus 1 times n plus 8 is the factored form of this problem. Okay? And we backed up and did it earlier, so we kind of knew that was going to be the answer. Now, does it matter if I put n plus 1 or n plus 8 first? No difference at all. It's the same thing. Okay? So get another example. Let's go with p squared plus p, but now it's going to be minus 56. Okay, so I'm going to start out my two binomials. My letter is p, or my variable is p, so I'm going to put p and p. Now I'm going to make my x. The top number is going to be a times c. My a value is 1. My c value is negative 56. So it's going to be negative 56. The bottom number is the b value. The b value, since there's nothing there, it's 1. Now, here's kind of a little trick. Something for your notes kind of on the side. There's really 4 ways that these can go. If the top is positive and the bottom is positive, so if you have a positive number on top and a positive number on top, both of those have to be positive as well. If you have a positive number on top and a negative number on the bottom, both of these are going to be negative. If you have a negative number on the top and a positive number on the bottom, one is going to be negative and one is going to be positive. The bigger of the two will be positive. The other and the last one that you could have is a negative on the top and a negative on the bottom. If you have a negative and a negative, the same thing's going to happen. One's going to be negative and one's going to be positive. So these are the 4 different ways that they could happen. So if we look at the one that we have, we've got negative 56 on the top. That's a negative, and a 1's a positive. So we've got a negative on the top and a positive on the bottom, which is this one right here. So that tells me one of my numbers needs to be negative and one of my numbers needs to be positive. Now understand, they have to multiply to be negative 56. So we go through the factors of 56. We've got 56 times 1. 56 divided by 2 is what, 28? I think 4 goes into it. 4 goes into it. 14? Okay. 4 times 14 is 56. One of them is positive and one is negative, right? What else is there? 9 and 6 and. Does 6 work? 6 doesn't work. 7 work? 7 and what? 7 and 8? Does 7 work? 7 times 8, 56? Now look at those. If any of them have a difference of 1? Do any of those have a difference of 1? What's the difference between those two? If I made one of them negative, what's one of it's 55, right? If I make those negative, it's like 26, right? Difference between those is 10, right? What's the difference between those two? What do we need our difference to be? 1. So this is what I'm going to use. I'm going to use 8 and 7. Now we have to figure out which one's positive and which one's negative. The 7 is going to be negative and the 8 is going to be positive. Negative 7 times 8 is negative 56. Negative 7 plus 8 is 1. So this satisfies my condition. So that makes this p minus 7 and p plus 8. And that's your solution. Okay. Comes down about being able to find the different factors of this 56 or negative 56 or whatever that factor or piece of it is. Okay. We're going to look at lots of these over the next couple days. Next one. Let's go v squared plus 4v minus 45. Okay, so we'll start out by writing it as a product of two of them. What comes first? What's v and v, right? A times C goes on the top. What's that value going to be? What's it going to be? Make sure you put that negative with it. But it's going to be negative 45 because we've got this negative right here. What goes on the bottom? It's my B value, so 4 goes on the bottom. So I need two numbers that multiply to be negative 45, positive 4. So the top is negative, bottom is positive. That means one of these is going to be negative, and one of these is going to be positive. So then we go down here and we just kind of think about the factors of 45. 1 times 45, that's obviously not it. 3 times 15, 5 times 9. We're looking for a difference of 4. Do any of those have a difference of 4? 9 and 5. Which one's negative? The 5 is negative. The 9 is positive. Negative 5 times 9 is negative 45. Negative 5 plus 9 is 4. So my solution is V minus 5 and V plus 9. And you're done. And again, we could correct it, but we're smart. We know we're right. Try the next one. Let's go x squared plus 13. Nice. X squared plus 13x plus 40. Give you a couple seconds to try this one on your own and see how you do. Those of you that are finding your phones much more interesting, I'm glad they're interesting, but this is second semester stuff as well that you're going to be doing. So you should probably be paying attention to what's going on up here instead of to your phones. You've had 2 weeks to do that at home. You've got the x and x part down all right, right? What number goes on top? 40. And what goes on the bottom? 40 and 13. So we've got a positive and a positive, so they're both going to be positives. Does everybody understand what I'm saying when I do that? Okay. So we look at our factors of 40. So 1 and 40, 2 and 20, 4 and 10, 5 and 8. We need them to add up to be 13, right? Which ones add to be 13? 5 and 8. You put 5 and 8, you put 8 and 5, does it matter? Does not matter at all. You could put it either direction. So it's x plus 5 and x plus 8. That's your factored form for that. Let's look at another one. Any questions with that one? Okay, so let's go with x squared plus 4x minus 32. What comes first? X and X. What's on the top? Negative 32 on the bottom. So we've got a positive, we've got a negative and a positive. So one's going to be negative, one's going to be positive. So 32, so 4 and 8. Which one's positive? Right? Again, how do you know which one's going to be positive? Because the bottom number is positive, the bigger of the two numbers over here is going to be your positive one. That's how I kind of look at it. So minus 4 plus 8. That's your solution. Let's do one more, and then we'll call it good. Let's go m squared plus 15m plus 50. Go ahead and factor that. So there's your answers on the board. So we're going to work on this next couple days with that leading coefficient just being 1. Okay, so these aren't going to go away for a couple days. It's kind of one of those things that is around for a long, long time in the mathematics world that we need to become pretty proficient at. So the assignment you're going to get today is going to be on this worksheet up here, and come and grab it in a second. First 4 questions are going to be the factoring by grouping, a little bit of review, and then the next, 11, 12 questions, somewhere right in there, are all about factoring these with the leading coefficient of 1. I have put this inside of Schoology, so it is there. Just kind of one more time, this guy, not a bad guy to kind of listen to. Brian McLogan is kind of his name. He does a lot of pretty good stuff. So if you're ever struggling with something, he's not a bad guy to listen to through this. So worksheet's up there. Come up and grab it. If you don't want to use this, you'd rather use it on Schoology, it's on Schoology as well. Make sure you submit it through Schoology, please. Submit it through Schoology. That way you can keep it. The answer